let me ask first, how many of you are aware of Verilog?
मैं क्या लाडले मियाऊं गॉप 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 गॉप.
So can you comment or respond? I mean, I want to understand the strength of batch. Okay, basic. Okay, so what about others? So everyone know basic Verilog or no, zero idea? So accordingly, I will take. Okay, okay. What about others? So anyone who is expert in the Verilog? Expert means he know how to do at least memory design, RAM design. No, no one. Okay, anyone about VHDL? Anyone have any idea? Hanji? Okay, no. What about others? And can you change these names to your proper name so that I can call and you can respond? This Ankita and Surya. So can you respond? Okay. So any of you have idea about VHDL or no idea? No idea on VHDL? You can even unmute and talk. Hanji sir.
No idea, sir.
Okay, good. And what about FPGA? Or do you know at least what is FPGA, or you do not have any idea, you do not know anything? What's comment on that? Hanji. FPGA, about FPGA, can you comment or? So what is FPGA, guys? Can someone tell me? No response, huh? Oh, someone commented. Basic information. So can you tell about that FPGA? Can you tell? It's a programmable device. Okay. Okay.
Sir, it is a device to test the designs. It is working properly or not.
FPGA. FPGA is a device to test the design. You are saying this?
Yes, sir.
So when you said design, so what is that design?
Mm,
So can you take an example of that design? No idea?
No, sir.
Okay. So others, anyone have any idea? So please respond. If I don't know about strength of the batch, then I might go either overview or I might go into the deeper. So hence it is required to evaluate the strength of batch first, and then we'll go ahead accordingly. So no idea? Actually, all right. So anyone have any idea about ASIC? ASIC?
Yes, sir.
What's that?
Sir, it is a application specific integrated circuit.
So you are just telling the full form. But what is that?
Sir, it is designed for a specific application, like for a specific purpose.
Okay. So, how to design that, or how? I mean, is there any similarity in between FPGA and ASIC, or there is no similarity? Anji, is there any similarity or no similarity? No similarity? Please respond. Huh? Then I will start. Actually, all right. One second. Yeah. So here we are just connected to cover that FPGA with the VHDL. So mainly we'll start on VHDL first, but before that you should know, you should also aware about the FPGA. Okay, and why it is required. If FPGA is not there, then what happen? If FPGA is available, then what is the plus point, or what is the advantage of having it? So like that will go. But still, I want to hear from you first. But I am not again getting proper response. So any leads last chance? So can someone tell me, is FPGA and ASIC both are related, not related? Sorry, last question. So can you tell me how many of you are college going and how many of you are working? So Akshata, what's your status? Are you college going? And Ankita and this one plus Surya and Vijaya. So Vijaya, maybe you are working, right? And about Surya, Ankita, Akshata, one plus. So can you tell me, guys?
Sir, college going.
Surya, which year?
Third year, sir.
Which college?
Centurion University.
Okay, good. So third year is almost done or started?
Started, sir. Started.
Okay, good. Then you should enjoy the session. Okay. And what about Akshata and Ankita and one plus? Actually, all right. So let me give you idea. We'll see in detail. Now try to understand here. Uh, in this digital world, so every device or every gadget is controlled by some specific thing, and that you can call either it could be a CPU, it could be a IC, it could be a chip, it could be a processor, right? So anything you can say, but ultimately everything is controlled by a particular IC, right? It could have a very less count in pin, and it might have a very large count on the pin, but everything is with respect to this IC. So let's say the very small example of a calculator. Let's say if I will talk about a calculator, and I want a calculator, and that calculator should be performed by any that IC or any circuit. So let's take that example. An operation I will take a adder. Okay. So now try to understand here. Now try to understand here this add operation. So what I want a circuit. I want a circuit that should take A and B, and that I should get output. I should get output as a sum from the circuit. Now, what is inside the circuit, I don't know, or how to fabricate or how to design that circuit or design that gadget or IC, that we'll talk. Okay. So, the basic idea of this conversation is basically we have a first requirement. So, we have requirement. Requirement, when I said requirement, so we have some specification. There are some specification, and those specification we want in the form of chip, in the form of IC. So now how it is possible? How it is possible? So the very basic idea is you can directly take wires. You can directly take wires and you can make lot of connection. You can make lot of connection, and those connections should be like that. You should get that sum equal to A plus B. So A plus B means A XOR B carries a different thing. I am assuming you are expert in digital electronics. Okay, so this A XOR B is nothing but A bar B plus A B bar, and this can be achieved. I mean, AND gate and NOT gate can be achieved by some connection only. If I will talk about this connection, so if I will talk about this connection, so what is this? What is this? Let's say this is A and this is Y. So here I should say y will be getting one if 1 minute. This is the input, and this is A and B. So this is A and B. Okay. So based upon this, we can say if any of switch is on, so I can get this power supply. I can get this power supply. So here I can say this is A or B. So this is A or B. And if I want A and B, so I can connect them in a series. Okay, so here I can write here I can write B and Y, and this is input. This is input. So basically, what I want to convey here, these gate we can prepare with the help of connection only. Okay, so this is the first approach, or this is the one approach which you can apply. This is the first approach. Now another approach could be the second approach could be, you might take the gates. आप गेट ले सकते हैं. You can take the gates, okay, and you can put them as required. You can put them, and you can make the connections. And then you connect it to the output. You can connect it to the output. So that could be the second approach. Now uh, these two approach are fine when you have very small circuit. But as your count of gate will increase, let's say here we are having 4 gates, and can you imagine if this 4 will increase to the 40, or to the 400, or to the 4000, or even to the 4 lakhs, then 4 CR. So can you imagine then? Is it possible? Answer is no. So now, what could be the other possible way? So the best possible way is we can do one thing. Uh, as count increase, we need to take the help of computer. That means computer is nothing but a set of software, right? And the software is nothing but the set of program, and that is nothing but some programming language. So we can have first that circuit in sorry that digital circuit in our hand, and then we can convert that circuit into some programming language. into some programming language. Okay, and then after that, what we can do? After that, what we can do with the help of some tool? With the help of some tool, we might get that named is nothing but netlist. So this process is I am not telling now, that we might see earlier, but I am sorry, later we might see later. But what I want to convey here, the different ways, and after this netlist, we can do the fabrication. Basically, based upon this netlist, based upon this connection. Netlist is nothing but the gate connection. So you will see the gate picture, the gate connection. So based upon that, we can do the fabrication, and then we can get our IC based upon the specification, based upon the request, based upon the requirement. Okay, so that will be the next IC. Now, uh, I will talk about a next method. So this is the third. This is the third one, the fourth way, and I'm interested in this. The fourth way. So this fourth way is actually very interesting, and what it is. So in the third way, what we are doing, based upon the specification, we are making netlist. That means netlist is nothing but a blueprint of our design, and then we are doing fabrication, and then we are getting a this board or IC. But the fourth way is a specific way in which we are first fabricating a board. Fabricating a board, and then what we are doing, we are fabricating a board, and we are making sure it is having lots of gates, and some registers inside this board, and those are designed in a special way, so that we can electronically turn on or turn off those registers. So we can turn on or turn off those registers. So what is special in this fourth way, we can have a first board, and based upon the requirement, so we can change the connection. And when I said connection, so connection is nothing but on and off. So we can make some connection enable and some connection disable, and those are nothing but some gates. So based upon our requirements, based upon our specification, we will get our circuit. So now finally, what we are getting, the same circuit, and with the required functionality. With this functionality, we are getting our same circuit. So first you tell me, I talked about first way, second way, third way, and fourth way. So let me talk about this particular example of sum or adder. So all will functionally same or not? Can you tell me, guys? Functionally all will same or not? Tell me. Can you tell me? So functionally all will act as a adder or not? Answer is yes. If it didn't make any mistake, so they has to be perform the same operation, and that is nothing but the adder operation. All right. One second. Yeah. All right. So can anyone confirm, guys? So all four will be functionally same or not? Tell me. No response. Yeah, Vijaya, Surya, can you respond? No response, guys. So answer is yes. Why? Because all were intended to work as a and operation, sorry, uh, adder, and all are working as a adder. But the thing is, the way in which we just design them or prepare them are different. So here I want to just conclude. So this first way, this can be achieved on a PCB board also. This we can achieve on the PCB board or even in the wire itself, right? With the wire itself, we can get this, right? So this is on the PCB board we can prepare. Now I will talk about the second one. So this second one can also be achieved on the PCB, but with the IC, with the gate IC. So let's say AND gate or gate, they are having IC also. So we can just make the connection and we can get that, right? So this is the second way. Now, how the third way is different from the previous one? So third way is the very interesting way in which first we are converting our design into a programming language. Okay, I will talk about this. That is nothing but through HDL. So we are describing our hardware into language, and then we are getting a net list, and based upon that net list we are doing some fabrication and we are getting the IC. So this what is this? This is nothing but our ASIC flow. So here what we are doing, it's a application specific integrated circuit. So what is this? What is the meaning of application specific integrated circuit? It means here our IC, whatever we design, so that is a application specific. So this IC is specific to a particular application. Means this IC can only and only perform the adder because it was fabricated or it was designed to perform only and only adder. And hence we are saying it is not general, it's not generic, it is specific. So this third flow is basically a ASIC flow. Now, what is this fourth way? This fourth way is where fabrication is already done in starting itself, and we are having that board ready with us, and with the help of program, we can change the functionality. We can change the behavior of this particular IC. So this IC is generic. This board is generic. This can be configurable. In lifetime, you can change the functionality. So this is nothing but it's a programmable board. So that's why the name of this board is nothing but field programmable gated array. That is nothing but FPGA. So what you can do with the FPGA, you already have a fabricated board. With the help of program, you can just do some on off, you can make some connection and you can get the IC. Now you are having the same board, but the same board can be used as a adder, and if you will change the programming, the same can be used for the subtractor. If you will again change the programming, then it can be used for the some multiplier and etc. But in the ASIC, what is in the ASIC? If you want this IC to be work as a subtractor, so you cannot use I mean in the future you will never use, you cannot use the same IC for the subtractor or multiplier, because that is application specific. उसमें सब कुछ फिक्स है, उसमें सब कुछ फिक्स है, that is specific, it's not generic. But FPGA is generic, you can program and you can change that. So that is the first thing which you should know about FPGA. So what is the purpose of having FPGA, and how it is different from other way, how it is different from the ASIC flow, and uh, then further we'll see how we can do the I mean this programming in the FPGA and what is the necessity of HDL, what are the HDL are supported, and if they are, then what is inside that HDL, that is VHDL and Verilog. So that we'll see. So now let me know. First thing is clear about this ASIC and FPGA. So what is this FPGA board? I will tell about the architecture later. But as of now, you should know the basic difference, the approach, how it is different from other, how it is different from the PCB board, how it is different from the that IC connection, how it is different from the ASIC flow. So guys, anyone have any doubt up to here? And do you have at least first level clarity? What is this FPGA board? No response? No response? Who all are in session? 1 minute. Okay, someone commented. Yeah, it's better you can just unmute and talk. So what about Sandhya, Rahul, Vijaya, this week? So are you getting or not?
Yes, sir.
Jyoti,
Yes, sir.
who respond?
Jyoti.
Okay. So all right. So this is the first level difference which you should know regarding FPGA. Clear? So now if I summarize here, so actually this ASIC flow itself require a lot of time to understand. It's a flow. It's a flow, right? And similarly, this FPGA also required some time to understand. So now I will not talk about this ASIC much. I will be explaining about this FPGA further. But if you want to understand ASIC flow, then you can go through it, right? So in the ASIC flow, up to netlist both are same. Up to netlist both are same, and then netlist can be used for the either for the FPGA and for the ASIC. Okay, so before that you should have that specification, and that you should convert to the language with the help of any HDL. Okay, it's like that. So let me just show you the FPGA architecture. 1 minute. So if you see, so this is the architecture of FPGA. Right. 1 second. Yeah. Yeah. So here. So here, just try to understand what is this. What is this? So this is the board. This is the board which is already fabricated. ये बोर्ड पहले से ही बना हुआ है. Now what you have to do? What you have to do? With the help of programming, you need to make the connection like this, like this, like this. Okay. And with the help of some connection, this board itself will work as a circuit, will act as a circuit. Okay. So how to program, that is a next story. But initially you should understand what is inside this, and what are the benefits of having this, and what are the limitations of having this. So I am having two questions. What is the benefit of having FPGA, and what is the disadvantage of having it? Can someone tell me? Hanji, can someone tell me? So what could be the limitation? No response.
FPGA is slower in speed, I think.
Okay. So okay, slow. And next, there is a one hit point, one critical point where FPGA will not be sufficient, or actually that will be an actual limitation. So slow is not a limitation. It can be I mean drawback, or it can be some performance issue, but where we will face the limitation issue. So I want to hear that, and that is not in ASIC flow. But all right, it's a good point. Yeah, can someone tell me, guys?
Maybe in terms of size.
In terms of size, yeah, you are near. You are about to answer. So when you said size, so can you be, I mean, go to more deep? Can you explain more?
Like if we just see the ASIC thing, it will be in the nano, like
Oh, you are talking about that size. Then no. Size is yes. Okay. So size is large with respect to ASIC, but it's
yeah.
not a limitation. Yeah. Still, I want to hear that.
Okay. Maybe one
Yeah.
more thing is there are some logic blocks which have some limitations. We can
Ah.
just use the functionalities which they have their high potential way. More than that, we can't expect from them.
When you said more than that, so what
Like
is that indicating here?
as you told, there will be some logic blocks and interconnects. So that logic, by using that logic blocks, there can be
Mhm.
some limitations where we can do some functionality wise. So more than that, we cannot use that logic blocks in terms of
Still, I didn't get. So when you said more than that, so you are focusing on the count.
not exactly like that. Maybe in terms of application wise, the
Oh,
use.
application wise. No. Then you are not right, because see, I will more talk about this block, but everything can be achieved from this block because they are having basic gates, and in our digital circuit, so with the help of basic gate we can achieve any circuit, right?
Yeah.
Yeah.
Yes.
So still I want to hear. Okay, let me give you a hint. When I said it's a programmable, when I said it's programmable, so this code is already fabricated, and I'm saying it's a programmable. So you tell me, uh, let's say these are the logic blocks. So how many logic blocks it have? 1, 2, 3, 4, and 1, 2, 3, 4. So it's having 16 blocks, right? No response. So this 16 is a finite number. I mean, if it is already fabricated, so obviously it should have some finite number of gates, finite number of blocks. And if there is a limit, if there is a limit, so we cannot use more than that number of gate. For example, let's say you purchase a you purchase some notebook, okay, or rough notebook. So you remember, if you are purchasing for 40 rupees and if you are purchasing some 80 rupees, okay. So the rate is based upon number of page. So 40 rupees is having, let's say, 100 page, and this is having 200 page. So this notebook we will only write, but what is the limitation? So we cannot go beyond the 200 page. We cannot go beyond 100 page, right? We cannot go beyond 200 or 100 page. Correct? But so this is you are already having a hard copy and then you are writing. So this is one way. Now another way is, first you are preparing a Word document, and then you will print them. Then you will print them. So try to understand here, guys. Whenever you are preparing a document, the document page can be 250, 260, 267, 387, any number, and then you can go for the print. But if you are already having a notebook, and then you can override that. So it's having a limit on the page number. So similarly, when you are going for the ASIC flow, so that IC will be fabricating at the last stage. So there is no limitation on the gates. You can design your circuit as many as possible. I mean large. So it could be. I mean there is no limitation in number of gates. You can have any number of gates. So I'm not saying it's good. Actually, the size will increase, cost will increase. That's a different story. Okay, but there is no limitation in the number of gates. But if you are using FPGA, okay, so there is a limitation on the blocks because you are having a finite block. You understood with this notebook and with this word example, right? Okay, but again same story, guys. From here also you can understand, if you are preparing word document and if you made a print, so they will be specific, you cannot override them. But if you are having empty notebook, so these notebook can be programmable, means you can write anything whatever you want, and you can erase them and you can write with the pencil. Okay, so here I put the same analogy. This is for the ASIC and this is for the FPGA. So you understood what is the limitation here? What is the main limitation? So that is, we are having finite blocks. We are having finite logic blocks, and we cannot go beyond that. Getting my point, guys, or not? No response?
Yeah, we understood.
Yeah. All right. So this is the, yeah. So this is the main limitation. So we are having finite uh, when I said finite, it is fixed logic block. Okay, so we cannot go beyond that. And what are the advantage? So what are the advantage? So the main advantage is it's a general. It's a general. So can be programmed. We are having lots of advantage, but this is the main advantage of having this. Okay, can be programmed. It can be programmed, and we can prepare that. So now I will talk more about this FPGA architecture. This FPGA architecture. So what is this? What is the smallest unit, or what is this block in FPGA? Can someone tell me more about this? What is inside this orange block, or what is inside this logic block? Anji, can someone tell me? So I will talk about component of FPGA. Okay, so we'll see. One second. Yeah. Core component of this FPGA. So which is nothing but instead of FPGA, let me write this CLB. So what is this CLB? First we'll understand what is this CLB. So this CLB is nothing but that logic block only. Okay, so this is configurable logic block. Okay, so here you saw this logic blocks, right? So it's that only. So what are the core component of inside this block? So we are having that LUTs. And what is this LUTs means? So these are lookup table. Okay, so lookup table. I will explain, don't worry about this. And we are having flip-flop, okay? And we are having that mux, okay? Now, let me explain the structure. It looks like, is it? Oh, I should take the shapes. Okay, so it's like this. So we are having this. This is your CLB. This is your CLB. Okay, and inside the CLB, you are having this. So what is this? This is nothing but LUTs. This is nothing but your LUTs, and you are also having that DFF, D flip flop, and after that, finally, second, what's the symbol? This I should take, or we are having directly. Yeah. So this is nothing but our mux. Oh, I mean, you can understand. So what is this? So this is inside. This is inside your our CLB. I will explain one by one. Just a second. हाँ जी, आप see. Okay, and oh, okay, and also it should be like this, right? And here we are having lots of inputs. So all input will go to this LUTs. All input will go to this LUTs. Okay, yeah. So this, and here we are having this clock. Oh, output also. Second, where? Yeah. So now try to understand what actually is this LUTs. So this is the same which I was talking about the basic gates, and we can achieve everything. So this LUT is nothing but it's a similar or analogy to the truth table. So truth table, you know, right? In the digital. So let's say if I want to achieve A XOR B, that A XOR B, Y equal to. So the truth table will be like this. So if A and B are having this and Y, so 0 0 0 1 1 0 1 1. So based upon that we will get some output, right? So so uh, uh, based upon this truth table, the Y will get this output. So similarly, LUTs are nothing but based upon the connection. So based upon the connection, we can get the desired gate connection. Now, why we are having this D flip flop and why we are having this mux? So this D flip flop is nothing but a register, right? And let us suppose this output is not available, or there is some programming is happening in this LUT. So in time being, this D flip flop can store that, and this D flip flop can provide that value through this mux. So here is the select line. So select line will select either the final output should go from the LUTs, or the same output, the stored output, should be driven from here. Clear? So this is nothing but CLB. So now this logic block, with the help of program, I will talk at the very last stage how programming will burn into FPGA board and how it will take care. But as of now, you can understand in our upcoming lectures, whenever I will say download program to FPGA board, burning program to FPGA board. Okay, so you should understand there is a concept of bit stream like 101110000001111111111000. So there is a bit stream which is coming uh, as a so for that programming, and then bit stream will take care and in entire board and whatever was the requirement, so that you can achieve through this bit stream. Okay, so now when I was talking about the limitation, so we are having limited logic blocks in every FPGA board. So if you are designing something and let's say you want to utilize more than the logic blocks which are available in the any FPGA board, so you know what happened, tool will throw an error like as many uh, what the error signature, I am not able to recall exactly, but it will be like exceeding the resources or exceeding the block, something like that. Okay, so you will get the error. So with respect to limitation, we are fine. And with respect to architecture also, we are fine with respect to FPGA and from where we start. So up to here, anyone have any doubt, you can ask. So up to here, what you should know? So you should know what is the concept of FPGA, why we are having FPGA, how it is different from the ASIC flow. So this question answer you should have. Now next thing is the basic architecture of the FPGA. So the basic architecture of the FPGA is it's having some logic blocks and programmable interconnect and some input-output blocks. And what is inside logic blocks? So that you should know there are three core components of this CLB, which is LUTs and flip-flop and mugs. So LUTs is equivalent to, or it's a kind of a truth table. With the help of that, we can achieve whatever we want. Okay. So if anyone have any doubt up to here, you can ask. Aji, anyone? No response? Anyone have any doubt up to here? No response, guys. Clear? Hai? Let me see the comment. Clear, clear. Oh, no doubt. Very good. Very good point. Okay. Okay. Uh, so then what's the difference between the truth table and all LUT? So, so truth table is on paper. Truth table is on paper. And LUT is a some logic. It has some wires and it has some gates. So that we are implementing in the LUT. You can understand like that. Okay. So truth table, you cannot implement that logic, but in a LUT, you are implementing that. Okay. Sorry, all right. So now next is, if you see the heading, so if you see the heading, FPGA with VHDL. So FPGA we discussed. Now next thing is VHDL. VHDL means how it is related to this FPGA. How it's related to this FPGA. What is the necessity of that VHDL? Can't we go directly? If we can go, then why we have this VHDL? So that we need to understand. That we need to understand. Okay? 1 second. So can anyone tell me why we need this VHDL here? Can't we go without VHDL? Hanji. Can someone tell me? No response? For high and digital output, since this is programmable device, we need to assign logic. Yeah, yeah, you are near. Yeah. Okay. So try to understand, guys, as I explained here, if you remember, so what is the first thing and what is the last thing? So the very first thing is we should have some requirement, that is, we should have some specification. We should have some specification. And if our requirement is very small, like adder, OR gate, implementing OR gate, implementing AND gate, implementing NOT gate, then it's a very simple one. It looks very simple because actually it's very simple. But the thing is, the circuit can be complex also, very complex also, and beyond our imagination also. So the first thing is specification, and the final thing is after programmable, this board should work as per the specification. So we need the help of computer if we are dealing with the complex circuit. And whenever computer is coming into picture, computer is nothing but some set of program. So computer only understands the language. It won't understand the digital. It won't understand the symbol. It won't understand any rest of the things. So that is why if we need a computer, then definitely we need to convert, or we need to equivalently put our specification or our digital circuit into some program, into some programming language. So ultimately we can say we need to describe our entire digital circuit in terms of language, or we can say entire hardware I need to describe in terms of language. Again, I can say entire hardware I have to describe in terms of language. Or in short, I can say I can describe my hardware in language. Or I can say uh, 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 that entire hardware is describing in a language. So that is nothing but HDL. So we need some library, we need some definitions, because program is nothing but some set of, that software is nothing but some set of libraries. So that is why we need a HDL. We need a HDL that will convert this specification to uh, that in terms of language, and that we can apply further operation on that HDL, that is netlist synthesis, that I will tell you later. And after that, through some another software, we can burn, or we can put that program or that bit stream into our FPGA board. So basically, because we want to use computer, so that's why that hardware needs to be defined in set of in program, and that's why we need to describe our hardware into a language, into programming language. So that's why we need something, and that something is nothing but the HDL. So this is the one HDL, which is nothing but the VHDL. So guys, can someone tell me the full form of this VHDL also? Can someone tell me the full form of VHDL also? No response? Can someone tell me? No response? Oh, someone. Oh, oh. Very high speed IC hardware. Yeah. Oh, so you are right. You are right. So it's a VHSIC HDL. So yes. So hardware description language is for this HDL. So HDL is nothing but that hardware description language, and this VHDL. So we are having VHDL and as well as Verilog. So Verilog HDL. Okay. So for FPGA you can use anyone. Okay. So this VHDL is for VHSIC hardware description language. Okay. Now this VHSIC is also having the full form. One second. That is very high speed IC. Mhm. Okay, let me ask a question beyond our requirement. So why we are having this long name for this VHDL? Why it's too long? Is there any reason, a valid reason behind this, or? Oh, Sai is asking what is the difference in Verilog and VHDL. Okay, so actually speaking, there is a lot of difference in Verilog and VHDL, but there are lots of similarity. And to answer your question in one line, so Verilog and VHDL both are HDL language. Okay, but this Verilog is having different library. When I said different library means the keywords, the formatting, and the structure is different in both the language. So VHDL is one language, Verilog is one language. So Verilog comes later, so it's advanced, but that doesn't mean both are not powerful. Both are powerful. Both are HDL, but Verilog comes later. So that's why it's a more. I mean, as of today, more in use. Verilog. Okay, and one more thing, it's very similar to C language, and it's whenever you are writing some program with Verilog, the program will not be bulky. So overall, we can say there are more features and it's more readable, more easy, and it's more similar to C. That's all about Verilog, but not in VHDL. But both are powerful, both are HDL, and both can be used for describing a hardware into a language. So that's all from my side. So can we start, guys? Now, what is next? So next we have to understand uh, about this language. What are the data types it have? What are the structure and how we can design? Then we'll see what are the modules we can have. What is the meaning of this test bench? What is the meaning of RTL? What is the meaning of this behavioral? And all those things. What all types of data type supported? How we can do assignment? What are the signals? What are the ports? etc. And then later on, or at the very last, we'll do some project also. Maybe I will try that FPGA project with VHDL. So like that I'm planning. So believe me, you will really enjoy the session, but have patience and don't miss any session. Again, I'm repeating for last time, have patience and don't miss any session. Okay, so today we'll have up to here only. Maybe in the next session we can start after this. So anyone have any doubt up to here, you can ask. Yeah. Anyone have any doubt? So one question you didn't answer. Why we are having this very long name for this VHDL? Is there any valid reason or just don't know? So as a homework you can see. Okay. And in the tomorrow session, I will tell about the LRM also, this VHDL LRM. Okay. And I will also talk about the tool. Okay. So if you can download that. Either you can work on the EDA playground, that is online simulator, or you can go with the Quartz Prime. So it's up to you. So please go ahead with that. And in tomorrow's session, I will tell how to download, or I will help you basically. Okay. All right. Thank you, guys. If anyone have any doubt, you can ask. Else you may leave the call. Thanks. Right. Thank you, everyone. Bye.